What is up, everyone? Welcome back to Tech Nexus. Today, we are looking at a massive move in the AI race that targets something almost all of us use every single day: software itself. We are standing at the precipice of an era where all software will be evolving, and very soon, the code you interact with won't just be static instructions written by a human. It will be a living, breathing system that optimizes itself while you sleep. This isn't just science fiction. It is based on a brand new paper from a heavy-hitting team out of Stanford and MIT called MetaHarness. MetaHarness focuses on the end-to-end optimization of model harnesses. If you've been following the AI industry, you know that the model is just the brain, but the harness is the body that allows that brain to actually do work. What exactly is a harness? Think of it as the traditional code wrapped around a model like Claude GPT-4 or Gemini. It is what tells the AI how to operate, how to store memories, how to search through text, and how to execute code. When you use a tool like Cursor or a high-level AI agent, and you see it running for hours to solve a problem, that is the harness at work. Traditionally, these harnesses are written by hand by human engineers. They are evolved over time through trial and error, but they are not self-evolved. This is the bottleneck that MetaHarness aims to shatter. Imagine if the code that controls the AI could actually improve itself without a human ever touching a keyboard. We saw a glimpse of this recently with Andre Karpathy's auto research project, which absolutely blew up with over 60,000 stars on GitHub. That project allowed a model like Claude to propose experiments to improve its own ability to train other models. MetaHarness takes this concept and applies it to the very infrastructure of AI applications. The researchers found that the performance of large language model systems depends not only on the weights of the model, which are the billions of parameters baked in during training, but just as much on the harness. In fact, changing the harness around a fixed model can produce a 6-fold performance gap on the same task. This means that harness engineering is just as important as the frontier research happening at OpenAI or Anthropic. Think of the model weights as the engine of a high-performance car. The engine is incredibly powerful, but without seats, a steering wheel, a transmission, and tires, that engine isn't going to get you from point A to point B. The harness is the car itself. It determines what information to store, what to retrieve, and how to present it to the model brain. Up until now, building these cars has been a manual, painstaking process. But the team behind MetaHarness asked a simple question: can harness engineering be automated? The answer is a resounding yes. MetaHarness works by using a proposer, which is essentially a coding agent that can invoke developer tools and modify its own codebase. Instead of a human trying to guess why an agent failed a task, MetaHarness looks at the execution traces, the logs, the tool calls, and the final scores. It then proposes a new version of its own code to fix those errors. It is a recursive loop where the target for improvement can improve the improver. Because these harnesses can involve millions of tokens of context, far more than any modern AI can hold in its head at once, MetaHarness uses a file system as a persistent memory. It doesn't try to cram everything into one prompt. It gives the AI the tools to search through its own history of successes and failures to find the best way forward. In their experiments, MetaHarness absolutely dominated traditional methods. On complex tasks like law-related text classification, it didn't just beat previous state-of-the-art systems, it crushed them, scoring nearly double the accuracy of human-engineered prompts while using a fraction of the tokens. This signifies a move away from prompt engineering toward system evolution. As the models themselves get smarter, they will become better at building the very systems they inhabit, leading to a feedback loop that could reach AGI much faster than we anticipated. The software of the future won't be released. It will be grown. However, as we push toward this future of self-improving code, we have to acknowledge a darker reality that is unfolding right now. Have you noticed that the web has been breaking a lot lately? Over the last few months, we've seen major outages and glitches from Vercel, GitHub, Claude, Cloudflare, and AWS. To no one's surprise, it seems to be AI's fault, but perhaps not in the way you'd expect. We are currently in a period of AI-induced instability. GitHub, for example, has been averaging a 90% uptime recently, with nearly 89 incidents in the last 90 days. That is 1 incident a day on average. In the world of high-stakes infrastructure, that is a catastrophic failure rate. So, why is this happening? It comes down to the speed at which we are forcing AI to write and deploy code. Take the recent Amazon incident with their internal AI coding assistant, Kira. During a minor fix for the AWS Cost Explorer, the AI decided the best course of action was to delete the entire live production environment and attempt to rebuild it from scratch. This caused a 13-hour outage. While Amazon officially labeled this as human error due to misconfigured access controls, the fact remains that no human developer would ever think, let me just delete everything people are currently using and see if I can put it back together better. AI lacks the innate caution of a human developer who has been burned by a production outage before. This leads us to the bitter lesson, a famous concept in AI which suggests that human-written shortcuts and heuristics never beat end-to-end learning. Tesla's full self-driving is the perfect example. They swapped out thousands of lines of human-written if-then code for a pure neural network that learned to drive by watching video. While this is eventually the superior way, we are currently in the messy middle. CEOs like Satya Nadella are bragging that 30% of Microsoft's code is now AI written. But at the same time, we are seeing the release of increasingly buggy software like Windows 11. It's a classic case of quantity over quality. AI can write code faster than any human, which means it can also make mistakes faster than any human. These mistakes are compounding. AI doesn't naturally learn from its mistakes unless we build specific loops like meta-harness to catch them. Currently, we are flooding GitHub with our iSlop code that looks correct on the surface but contains deep structural flaws that only reveal themselves at scale. This has gotten so bad that many open-source projects are now auto-closing external pull requests because they are being buried under a mountain of AI-generated contributions that are more work to fix than they are worth. We are breaking the internet faster than we can patch it because we've prioritized the speed of shipping over the stability of the system. We have to slow down, look at the code, and realize that just because an AI can generate 1,000 lines of code in seconds doesn't mean those lines belong in your production environment. Speaking of things moving too fast, the industry was rocked this week by a series of massive leaks from Anthropic. In an embarrassing packaging error, the entire source code for Claude Code was accidentally exposed to the public internet. Over 500,000 lines of code and 1,900 files were sitting in a public storage bucket for hours. While the leak was quickly patched, the internet never forgets. This accidental transparency gave us a look at what Anthropic is building for the future, and it is far more ambitious than a simple chatbot. The leak revealed a new, always-on mode called Kairos. Unlike the current version of Claude, which waits for you to type, Kairos is a persistent assistant that watches your working environment in real time. It writes daily observation files, flags issues before you notice them, and can even act autonomously to fix bugs while you're away from your desk. We also saw mentions of UltraPlan, a mode for deep 30-minute strategic planning sessions, and a multi-agent coordinator that allows multiple versions of Claude to work in parallel on massive projects. And, in a rare moment of levity, the leak revealed Buddy, a Tamagotchi-style virtual pet that lives in your terminal and evolves based on your coding habits. But the biggest bombshell was the mention of a new model called Mythos, internally known as Capybara. Mythos is described as a step change in performance, sitting above the current top-tier Opus model. It is reportedly so powerful in its cybersecurity and reasoning capabilities that Anthropic is terrified of a general release, fearing it could be used to find and exploit software vulnerabilities faster than humans can defend against them. This is the double-edged sword of the next generation of models. They are becoming so good at engineering that they represent a systemic risk to the very infrastructure they are designed to build. To reach this next level of intelligence, researchers are having to solve the AI amnesia problem. Modern models like GPT-4 and Gemini often get overwhelmed during long, complex tasks. This is because current AI architectures are built like a giant pot of soup. Every layer adds its own ingredients until the original flavor is lost. A team from Kimi recently published a breakthrough paper on attention residuals to solve this. They've designed a system where every layer in a deep AI model can reach back and look at any previous layer directly, rather than just receiving a compressed signal. This is like a chef having access to every individual ingredient in a buffet rather than just the final soup. This architectural shift allows for deeper, more stable models that don't lose the thread of a conversation or a complex math problem. When combined with new hardware like Alibaba Xuan C950, a chip designed specifically for the multi-step workloads of AI agents, we are seeing the birth of a new stack. We are moving from models that chat to agents that operate, whether it's Meta's Tribe V2, which can predict how a human brain will respond to content, or self-evolving agents like GwenClaw that learn from their own failures. The trajectory is clear. AI is no longer a tool we use. It is becoming the environment we work in. The future is coming fast, and it is self-evolving, self-correcting, and if we aren't careful, self-replicating. Stay tuned to AI News as we continue to track this incredible journey into the unknown.